All right, today's Deltamath assignment, I'm going to just start at the top, work my way to the bottom, and do a few of each. So the first one, we're looking at this, and you're going to need to remember from our notes today our transformation equation. So if you don't have this written down, write it down. Pause the video, write this down, because this is what I'm going to keep referring back to. So looking at this first question, this is a quadratic because it has a degree 2. It's a U-shape. So here's your quadratic equation. We need to make the solid line match the dotted line through transformations. So first thing, if it's positive, that means it's going up. If it's negative, it reflects it over the x-axis. So this one is going up. We're trying to keep it up, not trying to reflect it down. Then the next part of this question, inside, we're trying to make this graph move either left or right. So from my black graph to my red dotted, it is moving 1, 2, 3, 4, 5 left. Well, you should be comparing these 2 points. This point right here, your vertex, and this point right here, the vertex of the new one. So I moved it 1, 2, 3, 4, 5 left. And I also need to move it down 2. So 5 units left. Left is positive. So I need to put in a 5, a positive 5. And see, it moves it left. So I'm almost there. My equation's almost right. And if you look up here, it's changing your actual equation. So take note, I put a plus 5 inside the squared. So now it's going down 2. So down is on the outside and negative. So down 2 is negative 2. Down 2, that is correct. You can hit submit. So this equation went left 5, down 2. Not next section, next part. Okay. All right. This one isn't going up. It's being reflected down. Reflected down is the first one. So instead of positive, we need to make it a negative to reflect it over the x-axis, reflect it down. Now that they look pretty similar, I'm going to do my vertex of both of them and see how they change. So it goes first to the left 5 again, and up 5. So this point moves left 5, and this time it went up 5 as well. And you can count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So left 5 is positive inside my equation. So inside this parentheses, positive 5. I just move left 5. And now I still need to move it up 5. Up is outside my parentheses, outside my function. Positive. Up 5. Correct? You can hit submit. See if we can get some. I want to get a problem. Okay. All right. So this one is reflected down, so I'm making it negative. I'm going one vertex to the next. Going left, 1, 2, 3. Left, 3, and up, 1, 2, 3, 4. Up, 4. So left is inside my parentheses, positive. Left is positive. Up is also positive. All right, now we have an absolute value equation 1, but it's the same. It's the same steps. So as you can see, my V shape absolute value is flipped down now. So it's going to be negative, reflected down. And now I'm still looking at my vertexes. And I'm moving 1, 2, 3, 4, 5, 6. So now I'm moving right 6 and up 4. Right 6, right is negative. So I need to put in a negative 6. So that I'll move to the right 6. Up 4 is positive 4. Up is positive. Look at your equation. In front is negative because it reflected down. It's a negative 6, which is making it move right. It's a positive 4, which made it move up. All right. Any questions on that? Next section. So the second one, we are given the graph of the parent function. So this is just y equals absolute value of x. That's all that is. And we need to move it given the equation. So this equation is different from our parent function because of the negative 5 on the inside. Well, a negative 5 on the inside of my function, it's not squared anymore, it's bars, but it's still the same equation. A negative 5 on the inside moves it right 5. So I need to move this V shape right 5. So I'm just going to drag this 1, 2, 3, 4, 5. All right, it's still a absolute value question, still V shape. But now the numbers on the outside of my bars. Outside of my bars is either up or down. This is a negative 4. It is down 4. Negative is down 4. So I'm going to move that graph down 4. So I take one of those points, usually the vertex, the green one moves it, because you don't want to stretch it or compress it. So you always want to move the green vertex one down 4. 1, 2, 3, 4, because all the other points should move with it. All right, inside my absolute value bars, it's negative. Inside my absolute value bars, inside my function, it is negative 4. Negative is to the right. So this is right 4. Right 4. 1, 2, 3, 4. Right 4. All right, let's go to the next section. Now there's 2 transformations in each. So inside, positive is opposite. So positive is left. So I'm going to move it left 1. Outside's up and down. Negative is down. So left 1, down 2. Left 1, down 2. It's it. All right. Inside my bars, negative. Inside my bars, negative is right. So I'm going right 2. Outside is negative, down. So I'm going to go move my graph right 2, down 4. My vertex right 2, down 4. All right, this one's different because now it's not absolute values, it's a parabola because it's quadratic. It has a degree of 2. So that degree of 2 is just now my function. What it does is it changes this shape to a parabola. So now you can see our shape is a parabola. But the number is not inside with the x, it's still on the outside. So outside is up. So I'm going to move it up 2 because it's positive. Positive side. The last part is you writing the equation. So here is your vertex. Our parent function is an absolute value, and so you're plugging it in. It's not reflected down, stretched, or compressed, so there's no A. So what I always do when I write an equation, or function is y equals. So make sure you put your y equals when you turn this in. So it's not vertical stretch, vertical compression, or reflection, so there's no A. Was it moved left or right? Yes, it was moved 1, 2, 3, 4 to the left. Well, left is positive, so this should be a plus 4. So this should be a plus 4. Was it moved up or down? Yes, it was moved up 1, so this should be a plus 1. And you have your equation. So y equals the absolute value of x plus 4 bar plus 1. Plus 4 plus 1. All right, so now our equation is quadratic. So we have y equals a x minus h squared plus k. It's not vertically stretched, vertically compressed, or reflected down. So no A, that goes away. Was it moved left or right? Yes, it moved 1, 2, 3 spots to the left. Left is positive, so 3 spots to the left. And it's also moved 1, 2, 3 spots up. Up is also positive. So y equals parentheses x plus 3. The squared has to be there to give it that U shape, plus 3. Or if you want to just graph all these in Desmos, you can do that. It's a long way to do it, but you're more than welcome to do that. So left 3, up 3. Last question. Again, it's a quadratic, so I'm going to use the same transformation equation. A x h. The squared is what gives it the U-shaped, plus k. This one was reflected down. It was reflected down, so that means that A has to be a negative. That's how you get it to reflect down. So A is a negative. It was moved left 1. Left is positive. Left 1. Where H is. And then it wasn't moved up or down, so K goes away. No up or down. So your equation, what we're left with, is y equals negative x plus 1 squared. Which is this one. I'm going to do another one. They're writing it funny now. So here, this one is reflected down, so you know it has to be negative. So with your test taking skills, all of them are negative. So that didn't help eliminate anything. The next thing is it's moved 1, 2, 3, 4, right 5. Right 5 is inside my function. Right is negative, so I have to have a negative 5. It has to be a negative 5. So it can't be this one. It can't be this one. Negative 5. It has to be inside my function, so it has to be that one. This is outside. This would move it down 5. These can't be graphed in Desmos. These you just have to know. I hope that helps. If you need help with me, let me know.